Okay, problem number 7. Given the 2 points, C and D. Okay, take note the point C is in rectangular form, and then D in what they call this. This is in a spherical form. Because you have a radius R, theta 20 degrees, and then the P is equal to negative 70 degrees. Now, find first the spherical coordinates of C. This one, we can simply use the drawing, no? And then B, the rectangular coordinates of D. And then the distance from C to D. Take note, we're not dealing with vectors, okay? We're dealing with conversion of coordinates. So we can simply use the drawing that we have formed the previous meetings, okay? So let's start with problem A. So conversion of spherical coordinates of the rectangular coordinates C to spherical coordinates. Okay, so that's anyway. Sorry for that. Okay, so we have sorry for that. So we have C, so negative 3, 2, and 1. So we wanted it to convert into C, the same coordinate, but in terms of R, theta, and then the P. Sorry, it should be theta. Okay, so we can use the simple one. So first, we want to draw the spherical to get the R. So what is the R? So if you have a XYZ, okay, so if you have Y, X, Z coordinates, okay, so R is the radius, no, of a sphere. If you have a sphere, the sphere looks like, okay, so the radius is this one, okay. So we have the magnitude of this line, or the measure from the origin or the point, the center, to the surface of the sphere. Okay, we know that the magnitude or the distance from the center of the sphere and to the surface is equal to all sides, no? So the same R. Okay, but we understood that if we look at the top view of this 3D plane, so we have XY. This one is the P. Okay, this one is the P. So actually R and sorry, not P, rho. The R and rho are equal if theta is equal to 90 degrees. Okay, because we know that theta here, theta is the angle from the vertical to the R. Okay, so this is the theta. So that's this is theta, and then this is R. Okay, so if theta is 90 degrees, then R is equal to rho. Okay, because if you look at the top, so the radius is actually in the XY plane. Okay, so the XY plane. Now if theta is not 90 degrees, then R is not equal to rho. Okay, so there's a formula to that, no? Very simple. We know that R is related to rho, and then rho is related to XY, no? So the rho is just the resultant of X and Y. So there's a right triangle here, and then the rho is related to R given the angle theta. Okay, you understood? So what I mean is, if you look at the right side view or the front view, whatever you call it, so given Z and then given maybe Y or X. Okay, so let's say Y, because we're looking at the, sorry, this is front. If you're looking at the right, we have X. Okay, so if you're looking at this is the R, and then this is the rho, and then this is the theta. Okay, you understood the plane, right? You're looking at a sphere, then you look at the right view, so you will have this angle theta. This is the r and this is the rho. As I said, if theta is 90 degrees, then r is equal to rho. Okay? So in this case, so our theta is any value. Okay? So given the from spherical to rectangular, now it's easy to go to from rectangular to spherical. Very simple. First, given the x and y, so you can get the rho, and then given the rho, you can get the r. Okay? So how? So first, you have the rho. Actually, in the book, from the book, you have formulas directly. Okay? But I wanted you to understand this process so that you don't need to memorize. So first, we got rho, which is square root of x squared plus y squared. So this is equal to square root of negative 3 squared plus 2 squared. So this is 4 plus 9 is square root of 13. Okay, this is square root of 13. Okay, and then we have already rho, but our goal is r. So we have r. Now how do you get r from the right view? From this drawing here. So how do we get r? So we know that r is the we know that if you're dealing with theta, we know that the rho is opposite to that theta. So using sine theta, we know that this is opposite over the hypotenuse, okay, which is r. So therefore r is equal to, so r is equal to rho over sine theta. Okay, so very simple. But how do we get the theta? So we still need to solve for theta. We already have the rho, but still need to use the solve for theta. Now how do we solve theta given the drawing in the right view? So we know that z is given, right? G is equal to 1. Okay, so z is adjacent to theta. So therefore we can get, okay, we now have z, and then we now have rho. Then we can solve for theta. Okay, what identity or function? Tangent, no? So you have the tangent of theta is equal to opposite, which is rho over the adjacent z. Okay, so therefore theta is equal to arctan of rho, which is square root of 13 divided by 1. Okay, so what is the theta? So we have here 74.5 or 74.5 degrees. Okay, so that is your theta. Then we can solve for r. R is equal to square root of 13 over sine 74.5. Okay, so solving it, we have square root of 13 divided by sine 74.5. So we have, using your calculator, we have 3.741 or 74. It's okay. Okay, now the remaining value is the p. Okay, the p, how do you solve the p? We know that p is this in the top view. We know that p is here, no? The angle between x and the rho. Okay, so therefore we know that x is adjacent to rho, adjacent to p, and then so therefore we can use the cosine theta, di ba? So cosine theta, cosine p is equal to adjacent x over the hypotenuse, which is rho. Okay, so you have rho. So therefore we're looking for p. So p is equal to cosine inverse of x, which is negative 3 divided by rho, which is square root of 13. Okay, so this is from the top view. So by drawing the problem, you can easily get the formula. So this is very important because that makes you remember the the formula without memorizing the formula. So if you have only, so we have 146.31. Okay, so then you have the C coordinates. The C coordinate is equal to R, which is 3.74. Then we have the theta, which is 74.5. Okay, so that's positive. And then we have 146.31 degrees. Okay, so that's for our C. Okay, let's solve for letter B. So this is A, and we have B. Now for the B, the rectangular coordinates of D, we know that D is in spherical formula or spherical form. This is 5, 20 degrees, and then you have, this is 70 degrees, negative 70 degrees. And then we wanted to convert it to D, which is X, Y, and Z. Okay, so actually given the same drawing, without, actually we know that X is negative, but I just try to make it the standard form in the top view and then the right view. Okay, so that's a drawing. Okay, all positive, but the given is negative. Don't worry, this is still valid. Okay, okay, given the same drawing in the problem A, so we can actually derive the formula. Okay, so X, how do we solve X? Okay, given now in reverse, given the radius R, so we can solve for rho, and then given rho, we can solve for X. Now also the P is already given, so we can really solve X and Y. Okay, and then Z can also be derived from given theta and R. Okay, so that's the hypothesis. Okay, so we can work on it. So okay, so we already have P, which is 20 degrees. That's negative 70. So we can solve for rho, which is equal to, from this formula here, sine theta. So rho is equal to R sine theta. Okay, so given R, which is 5, then sine theta, which is 20 degrees. So rho then is equal to 5 sine 20 degrees. 1.71. Okay, so that's 1.71. Okay, take note that the rho is always less than or equal to R. Okay, the rho cannot be greater than R. So if you think, if you have an answer that is greater than R, then probably you're mistake, because sometimes you get a mistake here. So rho is equal to R over sine theta, or that one, no? So you already made a mistake. And then given rho and then P, we know that P is equal to negative 70. Then you can solve for X. X then is equal to what? Given the formula here in the cosine P, because X is adjacent to P, so we have rho cosine P. So therefore this is 1.71 cosine of negative 70. Okay, so this is equal to 0.585. Okay, 0.585. And then we can also solve for Y. Obviously that is the sine, no? If X is the cosine, then Y is the sine, no? You can verify it in the drawing. Okay, in the top view you can check this formula from the top view. Okay, so this is 1.71 sine of negative 70. So what is your Y? Negative 5?
Negative
61. And then you have the Z. The Z can be seen in the drawing right view. Okay, we see that z is the adjacent of theta, and then given r. So therefore, from the formula of tan theta, or you can also tan theta, no, because you have the rho, or you can use the cosine. Okay, cosine theta. We know that cosine theta is equal to z over r. So therefore, z is equal to r cosine theta. Or you can use, given the tangent, so you can also use, this is rho over tangent theta. Okay, but the simplest one is the r cos theta. Okay, so by looking at the right view, okay, your basic trigonometry, you can solve for z. Okay, so this is 5 cosine 20 degrees. So z therefore is equal to 4.698. So this is 7. Okay, so I just write for 7. So therefore you have so your answer then is equal to d, x is 0.585, and then your y is negative 1.61, and then your z is equal to 4.7. Okay, so this is how you get the cylindrical the rectangular coordinates given spherical coordinates. Okay, so this is your final answer. Now, how to get the distance from C to D? Okay, you can either use the all rectangular, you have the rectangular form of C and D, or you can also use the spherical formula of both C and D. But the most obvious way of getting the distance is using the rectangular. If you watch the previous video of the getting the distance between 2 points, okay, so rectangular form is the best, no, because we can simply use this formula. Okay, d is equal to square root of the difference of each rectangular points, I mean the axis. So x2 minus x1, y2 minus y1, and then z2 minus z1 for rectangular form. So you have x2. Now, instead of 1 or 2, we use d or c. xd minus xc. Now, if you notice, you can interchange xd and xc. You can use xc minus xd. Regardless of that, still you will get the same answer because this is squared. Okay? So, xc minus xd squared is still the same, no? Okay? Because this is only magnitude, this is scalar value. Then you have yd minus yc plus zd minus gc. Okay? So as I said, you can interchange the points, no? Either point C minus point D. And this one is equal to xd, which is the d is the one we have in problem B. So this is 0.585 minus xc, which is negative 3. So minus negative 3. So as I said, in most of my videos, I wanted you to write this form, no, minus negative, okay, so that you can easily check, no, if you really copied the correct number value. Otherwise, when you check, it will be difficult, no, if you don't write. If you suddenly change it to positive, and then when you look at C is negative 3, you might be tempted to write negative instead of positive, no? Then you will end up confusing. So we have yd is equal to negative 1.61 minus C. So this is 2 squared plus 4.7 for zd minus zc, which is 1. Okay. And then this one is equal to what? Now this distance formula is actually can be derived from our previous video. This is the dot product of the two. So this is actually D is actually equal to, if you're using the 1/2, okay, the 1/2 of um, you create a vector RC, then uh, then that this one should be RC or RD minus RC, or RC minus RD is okay. RC. So this is not 1/2. Okay. If you're going to get the area, then you will use the 1/2, no? And then cross product. But this one is the difference between RD and then RC. Okay. So in this case, if you're going to use this, you can also use the spherical formula, but it will be difficult, no? To use the spherical formula. So you need to change it to rectangular formula. So this is the so what is the value? 6.29 units. Okay. Now I want you to check also. There's our function, our calculator can actually solve for this. Okay, without manually doing like square root of squared plus square root of squared. No, can actually use our calculator in this. So I'd like you to check. So we have here our calculator. So our calculator here, so you can check the mode vector. So there's a vector number 8. It depends on your calculator, no? So vector number 8. Then you write first vector A. So vector A is, we can put it as vector C. So then we use, in the calculator can, in this calculator, only three values. So you write the 3 vectors. Okay. So what are the 3 vectors in our so we have XD. We can write vector A. We assume this is vector C. So this is -3 equals 2 equals 1. Okay. So here, no. So you have -3, 2, and 1. And then if you want to change to vector B, so shift vector, and then dimension, and then press 2 for vector B, and then 1, 3 coordinates. Okay, so we assume that this one is vector D, so which is 0.585, then -1.61, and then we have 4.7. Okay, so we already have the two. So we already have 2 vectors in our calculator. We can actually solve it, no? You can shift vector. Okay. This is data. So now we can actually get the magnitude. Okay, shift vector. Okay. First you press AC, no? Then get the what? You get the vector 3. Vector 3 is vector C, then minus vector B, which is 4. Okay, but if you notice, there's no magnitude in this, but we can do this. So we have these values, and then how to get the magnitude? So in this calculator we cannot get the magnitude, but let's try the dot product. So the calculator, you can only use it for dot product and cross product. Getting the distance between 2 points, you do it manually. Okay, but you can get the difference vector, or the vector difference of the 2 vectors. Okay, but getting the distance, you do it manually by taking the root mean square of the resulting vector. Okay, so that's it. So we have solve problem number 7.